All right. Look at this point of interest. It says the movie Apollo 13, starring Tom Hanks, was filmed in part in what they call a vomit comet, which is an aircraft that uses a parabolic flight trajectory to produce weightlessness. As the plane climbs toward the top of the parabolic path, occupants experience a force of nearly 2 Gs, which is twice their body weight. Once the plane goes over the vertex of the parabola, flyers free fall inside the plane. Such motion often produces motion sickness, thus earning the aircraft its name of the vomit comet. All right. So parabolas make other people want to throw up too, not just you college algebra students. So, all right, let's look at example 5. Here's an application problem called an optimization problem. Now the goal is to maximize or minimize the value of the dependent variable y by finding an optimal value of the independent variable x. Okay? The first thing in a optimization problem is to write your function in one variable. Right now we've got 2 variables, x and y, and these have to do with the 2 chicken coops that are being built next to one another using 120 feet of fencing. All right, so we know that this 120 feet of fencing, okay, is the x plus x plus x. We have 3 of those x amounts added to y plus y plus y plus y, 4 of those y amounts. Okay? Now we need to solve this for one of the variables. Okay? I say let's solve it for y, so we'll have a function in x. So I'm going to subtract 3x from both sides. Minus 3x equals 4y. Then divide everything through by 4. Okay? And so what we're saying here is that this y amount can be expressed as a function of x, okay? So 120 divided by 4 is 30 minus 3/4 x, okay? Keep that in mind. Now, on part A, it says what dimensions should be used to maximize the area of an individual coop, okay? All right, so if we want to maximize the area, notice that the area of the chicken coops that use the 120 feet of fencing, okay, the area is going to be x times y for that first one and x times y for that one. So altogether, the total area is 2xy, okay? Now, what we want to do is we want to write our area function just in terms of one of our variables. I'm going to choose x because we already have a statement over here that relates, or actually writes, y as a function of x. So I'm going to bring down the 2x here, and instead of saying times y, I'm going to say times 30 minus 3/4 x. I'm going to write y like that. So now we have our area function expressed as a single variable in x. All right, let's clean this up a little bit. So a of x is 2x times 30 is 60x minus 2x times 3/4 x is a, let's see, negative 6/4, or that will reduce to negative 3/2 x squared. Okay? Now, since this is a quadratic, I'm going to go ahead and write it in descending powers. I'm going to write the negative 3/2 x squared term first, and then the plus 60x. Okay? All right, now this is my area function that I am going to try to find the maximum dimensions of, okay? All right, and really when I use that, I'm just going to say it's going to be an x by y coop, All right, when we maximize area, that is going to occur here at the vertex of this parabola, okay? So remember how, if this is your A and 60 is your B, how we find the vertex of the parabola. We take the opposite of B over double the A. So the opposite of 60 is negative 60 over 2 times a negative 3/2. There's double the A. So this will be negative 60 divided by, the 2's reduce here, just leaving us with negative 3. And so 20 is the maximum X value. All right? And then let's see, well, actually, if X is 20, okay, then we can go right back up here and figure out what would Y be, okay? If X is 20, then Y is equal to 30 minus 3/4 times 20, okay? And that's going to give us 30 minus the 4 and the 20 will reduce, leaving us with 15. So 30 minus 15 is 15. All right? So what this is saying is when X is 20, Y will be 15. Okay? And so this is going to be a 20, let's see, foot by 15 foot. That is going to produce the maximum area, and we can actually multiply those together to see what the maximum area is going to be. Or we can go back up here to our area function. This is going to be a little bit more, we're going to get 300, but there's 2 different ways to do it for the maximum area. How about we say, well, what's the area, actually, when X is equal to 20? So the area at an X value of 20, which is like kind of the width of all of each of these coops, that is going to be negative 3/2 times the 20 squared. I'm looking right up here is what I'm doing. And then plus 60 times 20. Okay? So this is going to be negative 3/2 times 400 is the square of 20. Plus 1200 is what we get there. Now we're going to reduce a little bit here. 2 will go into 2 once. 2 will go into 400 200 times. So we're going to have negative 600 plus 1200. That gives us 600. Now, y'all, 600 is going to be the total area altogether of both of those coops, okay? So it's going to be 600 for both coops. So the area of one coop, of an individual coop, is 300, and the label on that should be square feet. That's how we measure area, right? In square units for one coop. Because I don't have enough room to write individual coop. Okay? All right, and that is, again, what 20 times 15 is for the area of one coop. All right, so now let's fill in the blanks. A function defined by f of x equals ax squared plus bx plus c, where a is not equal to 0, is called a quadratic function. The vertical line drawn through the vertex of a quadratic function is called the blank of symmetry. It's the axis of symmetry. Given our function f of x is equal to a times the quantity x minus h plus k, where a is not equal to 0. The vertex of the parabola is the point hk. Okay? Given f of x equals, okay, that's a parabola in vertex form. If a is less than 0, that means a is negative, then the parabola opens up or down, right? If a is negative, it's a downward opening parabola. And the maximum or minimum value is what? Okay, well, we're talking about, we're going to have, with a downward opening parabola, we're going to have a maximum value, okay, and it has to do with the coordinates of the vertex. Remember, the vertex in this form is hk, and the k value is actually k. That is actually the max or the min. All right, on the flip side of that, on number 5 here, it says given a quadratic function written in vertex form, if a is greater than 0, all right, if a is greater than 0, we have a happy little parabola because it's positive, so that parabola opens upward. If that happens, we're going to have a minimum value, and it's going to be at the vertex again. So the minimum value is going to be k. So on number 6, the graph of f of x equals a times the quantity x minus h squared plus k, where a is not equal to 0. That means we have a parabola. Okay, the axis of symmetry is the line given by, remember, it's going to be the vertical line that goes through the x-coordinate of the vertex. Okay, so its equation, I'm going to write it down below because I don't have enough room on the line. Its equation is just going to be the vertical line x equals h. Oh, that's it for 3.1. So go ahead and do that homework once again. We're going to be graphing some parabolas, so make sure you not only show all work, but that you graph these using graph paper. See you in 3.2.